castings. They'll have a casting block that'll make 100 Matchbox cars at a time. I mean, we just make that real big. Yeah, I mean, we have the Cathedral of Casting back there. So yeah, let's do that. I mean, let's see, what is the limit of physics of how big can a casting machine be? Let's find out.
If you still think the EV race is about battery capacity or driving range, you've already lost. The game now is production speed, and Tesla is leading it by casting an entire vehicle frame in just 3.75 seconds. At Giga Texas, the 50,000-ton Giga Press is producing a complete Cybercab or Model 2 body in under 4 seconds. In the near future, that same technology will bring down the production time of the Model Y and Cybertruck to under 6 seconds, and drive the dream of mass-market self-driving cars rolling on the streets as early as next year. While competitors are still welding together hundreds of parts, Tesla's fully automated line operates inside a no-human zone, where robots and AI control every step, from mold oiling to X-ray inspection. So what does a Tesla built in 3.75 seconds look like? Is it real, or just another marketing number? Welcome to Tesla Car World. How is the 3.75-second EV production process happening?
Real fast. And then I guess maybe we need to just get even bigger casting machines? Sure, why not? Let's 50,000 tons.
At the heart of Tesla's most advanced Giga Texas, a full electric vehicle body is being produced every 3.75 seconds. If you step inside Giga Texas or peek into the production lines of Tesla's next-generation Model 2 and Cybercab, it becomes evident that this isn't marketing fluff. It's automation in a way no automaker has dared before. What we're seeing is the emergence of a new manufacturing paradigm, one where a vehicle's body isn't constructed through assembly, but rather born whole from a mold. The 3.75-second casting cycle may be Tesla's most staggering achievement yet, because it fundamentally alters the rhythm of the automotive industry. It's not just about speed, it's about simplicity. When you reduce the number of parts in a vehicle by 60 to 70%, you slash not just cost, but also opportunity for failure, maintenance, and warranty issues. You also redesign logistics, storage, shipping, and repair. Elon Musk has long compared Tesla's next-generation production lines to giant toy factories, and that metaphor isn't just poetic, it's literally what's happening. The company is turning die-casting technology, once reserved for small-scale metal toys, into the core of global EV production. Each time a Giga Press cycles, 5 Model 2 or Cybercab chassis may roll out. In a week, one facility could theoretically produce hundreds of thousands of vehicles with fewer workers, smaller footprints, and tighter integration than any automotive plant in history. The foundation of this breakthrough is the 50,000-ton Giga Press, the most powerful die-casting machine ever deployed in automotive history. While the earlier 6,000-ton and 9,000-ton presses revolutionized production by consolidating 70 to 100 parts into a single aluminum casting, the new 50,000-ton beast operates on another level entirely. Using a refined aluminum alloy, heated to nearly 850 degrees Celsius, the press injects molten metal into an enormous mold shaped like the underbody of a Tesla. And it does so under immense pressure, enough to compress a steel container flat in a second. The speed at which this press operates isn't just fast, it's borderline shocking. From metal injection to solidification, extraction, and restart, the entire process runs like a precisely timed orchestra of heat, pressure, and automation. Watching this machine in action is like observing an industrial ballet, but you won't see any human dancers on stage. The Giga Press and its surrounding zone are completely off-limits to workers. This no-human zone is a necessity more than a luxury. The environment is hostile. Molten metal, extreme heat, hydraulic pressure, and high-speed moving parts create a space where a human hand simply doesn't belong. Instead, everything is done by machines. Robots monitor the process from all angles while human technicians sit behind reinforced glass, managing operations via screens, sensors, and AI-driven diagnostics. This isn't the factory floor of Detroit in the 1950s. It's more like a robotics lab fused with a space launch control room. What truly transforms this setup from remarkable to revolutionary is how Tesla combines megacasting with 3D printed sand cores, an approach that makes it possible to create hollow sections within the cast aluminum structure. These cores are temporary molds printed from sand using BinderJet 3D printers. They're designed to create internal pathways for wiring, cooling tubes, and structural support channels. During the casting process, the molten aluminum flows around these sand cores, solidifies, and then the sand is removed, leaving behind a clean, hollow internal architecture. This method, borrowed from aerospace and precision engineering, allows Tesla to integrate far more complexity and functionality into each cast body section, while eliminating the need for dozens of post-assembly components. By removing traditional assembly steps and replacing them with integrated casting, Tesla is effectively building cars more like smartphones, pre-assembled, minimalistic, and designed from the ground up for robotic construction. Every cycle of the Giga press becomes a closed loop. The mold is lubricated with soybean oil, vacuumed to eliminate air pockets, injected with metal, rapidly cooled via conformal channels that follow the exact curves of the cast, and then opened to eject the part, still glowing from heat. A robotic arm transfers the fresh casting to a cooling bath, trims the flash metal, inspects for defects using X-ray and AI visual recognition, and then begins again. The entire cycle can complete in under 4 seconds. If one factory runs 2 presses simultaneously, Tesla could theoretically produce a completed car body every 1.875 seconds. It's no longer just mass production, it's hyper-production. But as with any wow for our and team one in the one there are technical hurdles. Die casting at this scale requires pinpoint thermodynamic control. If the aluminum is injected too quickly, air bubbles form, weakening the structure. Too slowly, and the metal begins to cool before filling the mold, resulting in incomplete or deformed castings. The molds themselves are subject to intense thermal stress, cycling between 850 degrees and near-freezing water sprays hundreds of times per hour. Designing and maintaining these molds becomes a full-time engineering discipline in itself. And then there's the challenge of removing the 3D printed sand cores cleanly, especially for deeply embedded passages. And for all its challenges, Tesla seems committed to scaling this method further. Even as competitors like Hyundai, Volvo, and GM are slowly adopting their own 16,000-ton casting presses, Tesla has moved far ahead. The transition from manually welded frames to single-shot aluminum architectures mirrors the shift from analog to digital. Not gradual, but explosive. So, why is Tesla building entire cars in just 3.75 seconds? Tesla's journey with gigacasting began with the 6,000-ton Giga Press, which revolutionized production by replacing over 70 welded parts in the Model Y's rear chassis with a single, solid, aluminum piece. This alone was considered radical in the automotive world. Then came the 9,000-ton version for the Cybertruck, handling even larger, more complex components. But today, the spotlight belongs to something far more disruptive: the 50,000-ton Giga Press. This colossal machine is not only capable of producing multiple car frames simultaneously, it's doing so with record-breaking speed. What once took 70 seconds per casting now takes less than 5 seconds. According to the latest reports from Tesla insiders, early production trials of the Cybercab chassis at Giga Texas have achieved complete chassis casting in as little as 3.75 seconds. Yes, less than 4 seconds from molten aluminum to a fully formed car body. At first, even Musk admitted it sounded crazy, but the numbers are real. Tesla's new production line is no longer just fast. It's redefining the tempo of modern manufacturing. One gigapress can now produce over 900 frames per hour, a staggering leap forward compared to traditional body-in-white lines. This makes Tesla's system the fastest high-volume EV production method on the planet, potentially doubling the output of even the most optimized competitors. So what makes this 50,000-ton press so different? The 50,000 tons refers to the amount of clamping force the machine applies, not its weight. That said, the press itself is still a monster, weighing more than 3,700 tons, over 8 million pounds, stretching over 130 feet in length, 40 feet in width, and towering over 30 feet tall, roughly the size of a 4-story building laid on its side. Installing it takes several months and requires its own reinforced foundation, specially engineered to absorb both vibration and heat. Inside this machine, Tesla has developed a 2-furnace system, one for melting aluminum at around 850 degrees Celsius, gas-fired, and another for maintaining the molten metal at optimal temperature, between 750 to 850 degrees Celsius, electrically heated. Before each cycle, nitrogen fills the holding chamber to prevent oxidation, while a combination of argon gas, rotary degassing, and fine filters removes impurities from the molten alloy. Then comes the mold preparation. A robotic sprayer coats the steel mold with a thin layer of soybean-based oil, around 35 millimeters per shot, which prevents sticking and ensures clean release. A high-speed piston, also lubricated with about 8 millimeters of oil, injects molten aluminum into the mold cavity. A vacuum is applied to remove any trapped air, enabling perfect filling at extremely high speed. Once the aluminum is inside the mold, it begins solidifying instantly. The mold is cooled using a conformal cooling system, where channels follow the exact contours of the part, allowing for faster, more uniform cooling. Within 3.75 seconds, the part reaches a solid state and is ejected from the mold at approximately 400 degrees Celsius. It then enters a cooling bath that quickly reduces its temperature to about 50 degrees Celsius. Robots trim excess metal and conduct real-time quality checks using X-ray imaging and AI-driven vision systems. Tesla's engineers have even designed a new generation of smart molds that monitor pressure, temperature, and flow rate inside the cavity in real time. These insights are used by AI to detect any deviation before a defect can form, allowing the system to adapt instantly. What does this mean in practical terms? Well, instead of using 1,000 robots to weld together hundreds of individual parts, Tesla now uses around 300 to handle everything, from raw metal to finished chassis. The result is lower production costs, less factory space, and much higher reliability. This one-shot casting approach also improves structural integrity. With fewer joints and welds, the vehicle's body is stronger, stiffer, and lighter. That translates into better crash performance, lower energy consumption, and increased driving range, all key selling points for EV buyers. Critics once dismissed the idea as too ambitious. Many believed aluminum molds couldn't survive repeated cycles without wearing out faster than traditional steel dies. Yet Tesla proved them wrong. The durability of these molds has been extended using advanced coatings and temperature cycling controls, making Giga casting not just viable, but scalable. The Model 2 are the first vehicles fully designed around this manufacturing philosophy. Tesla aims to scale production of these models at unprecedented volumes, millions of units per year. With this speed and simplicity, producing a car body in under 4 seconds isn't just possible. It's happening right now. Each cast body flows directly into Tesla's Unbox assembly line, an ultra-compact robot-managed area where battery packs, drive units, and interior modules are snapped into place like Lego blocks. There's no traditional assembly line here, no conveyor belts or teams of workers with pneumatic tools. Instead, it's a closed-loop system where metal, data, and electricity meet. How is Tesla 50,000-ton Giga Press technology being applied in other industries? At first glance, the idea of casting an entire machine in one shot seems exclusive to automotive innovation. But step back, and the same principles, modularity, reduced part count, rapid cycle times, and intelligent automation, start to make sense in places no one anticipated, including aviation, construction, and even heavy industrial manufacturing. So bring the Giga Press to Boeing. In the aerospace industry, the fuselage and wings of commercial aircraft are still built using thousands of hand-fitted aluminum panels, held together with millions of rivets. The process is not just expensive, it's fragile. Tiny imperfections or misalignments can create drag, reduce efficiency, or even compromise safety. Imagine instead an aircraft subframe cast in one shot, with built-in structural channels, wiring ducts, and reinforcements printed directly into the mold. No rivets, no panels, no misalignments. Just seamless, high-integrity aluminum or titanium alloy frameworks that could slash assembly time and improve aerodynamics. This line of thinking isn't hypothetical anymore. Recent patents in the aerospace industry suggest Boeing and others are now exploring monolithic casting and additive hybridization for select non-critical substructures. At the same time, NASA has begun testing large-scale metal casting techniques for modular satellite components and rocket engine parts. Whether directly inspired by Tesla or not, the direction is clear. Industries long reliant on hand-assembled structures are now flirting with the idea of massive integrated casting. Of course, the pressures and tolerances in aerospace are vastly different than in automotive applications. The metals must withstand extreme temperature variation, vibration, and fatigue over thousands of flight hours. And yet, this is precisely where 3D printed sand cores and conformal cooling, technologies pioneered inside Tesla's Giga Press program, could find new applications. Instead of hundreds of machined or extruded parts bolted together, imagine Boeing casting large structural elements of a fuselage or engine housing with integrated wire harness channels and embedded mounts. It wouldn't just reduce weight and complexity, it would change how we imagine building things that fly. The construction sector, too, is beginning to take notice. At first, building and auto manufacturing seem worlds apart, but look closer, and the parallels become clear. Concrete molds, prefabricated steel frames, and increasingly modular building components all speak to the same desire: simplify, integrate, accelerate. Imagine large-scale gigapresses adapted for casting building components out of composite metal alloys, pre-formed wall sections, utility channels, or integrated support beams. In a few years, we may look back at Tesla's Gigapress the way we look at Ford's first moving assembly line, not just as a breakthrough in one factory, but as the starting point for a total reinvention of industrial manufacturing. For now, the Gigapress is still mostly associated with the automotive world, but its influence is spreading quickly, and as more companies witness the impact it has had on Tesla's production speed, cost, and structural strength, the question is no longer, will they copy it? But, how fast can they license it? And maybe that's the ultimate sign that Tesla's game is changing. It's no longer just about building electric cars faster. It's about selling the future of manufacturing itself.
Something I've been thinking about for a long time, and I've sort of been thinking about this for a long time, and it's kind of, it's not a crazy thing. Like a car every 5 seconds may sound like it's coming out like bullets, but actually
Tesla's production statistics started making headlines recently, like 45 Teslas rolling off the line every hour. We were like, wait, what? That's 1,080 cars a day, non-stop, around the clock. Insane. A feat so impressive, even Henry Ford would take a second look. But here's the thing. How the heck are they pulling this off without sacrificing quality or safety? At that scale. Seriously. That kind of output sounds more like something from a sci-fi assembly line than real life. And yet, here we are. In the next few minutes, we'll dive into the secrets behind Tesla's cutting-edge automated production line and why you, the consumer, are the biggest winner in all of this. Welcome to Tesla Car World.
It's really just a first principles approach to manufacturing that will ultimately allow us achieve a cycle time, meaning a unit every 5 seconds or less, off a single line.
It all starts with a beast of a machine that most people outside the industry have probably never even heard of, the Tesla 50,000-ton Giga Press. This monster doesn't just shape metal, it confidently cranks out full vehicle underbodies in just 5 seconds flat. How is the 50,000-ton Giga Press linked to Tesla's ability to produce 45 EVs per hour? You can almost hear it, the roar of molten metal, the thunderous strike of a machine reshaping the future. It now takes just 5 seconds to complete the underbody of a Tesla. Faster than finishing your morning coffee. Compared to industry titans like Toyota or Volkswagen, who manage 20 to 30 vehicles per hour per line, Tesla's 45 finished EVs per hour is not merely impressive, it's redefining what's possible. But make no mistake, behind these astonishing numbers, there's no magic wand. This leap is the result of Tesla's obsession with vertical integration and relentless process optimization. And at the heart of it lies one of the boldest manufacturing innovations in decades, Giga casting. Traditionally, building a car's rear underbody was a painstaking process. It required over 70 individual parts, each welded, riveted, and meticulously aligned. Every weld was a potential weak point. Every rivet added complexity. Every step consumed time, manpower, and introduced opportunities for error. This was simply accepted as the way things were done, until Tesla asked a fundamental question. What if you could build the underbody as a single piece like a toy car? Answering that question led to the creation of Giga Press, a machine so massive and powerful that it reshaped what automotive manufacturing could even look like. With the Giga Press, Tesla replaced 70 parts with one giant aluminum casting. Using a proprietary aluminum alloy, the molten metal is injected into an ultra-precise CNC machined mold at enormous pressure, forming an entire underbody in under 2 minutes. No welding, no riveting, no assembly line delays. This isn't just faster, it's smarter. By eliminating joints, Tesla dramatically reduces dimensional errors, stress concentration points, and vibration issues that traditionally plague car bodies. And because each casting is formed in a high-precision mold, tolerances are maintained within 0.1 millimeters, an astonishing level of consistency that even the most skilled human workers cannot match. The Giga casting technology is not only revolutionary in its process, but also in the impressive numbers it delivers. The production time for the vehicle underbody has been reduced by up to 90%, while the cost of frame manufacturing has dropped by 40%. At the same time, the use of raw materials has become significantly more efficient, leading to a major reduction in robot maintenance costs. Moreover, the finished products now achieve greater durability and enhanced structural integrity. In short, Tesla is not just building cars faster, they are producing better, cheaper, and more consistent vehicles all at once. This is why, with casting speeds this high, a single Giga Press-enabled line can produce over 700 vehicle frames per day. It's how the seemingly impossible 45 cars per hour becomes the new normal. Many assume automation success is about throwing more robots onto the factory floor. Tesla understood something deeper. The true key to automation is simplification. Rather than automate every tiny weld and rivet, they eliminated the need for most of them altogether. Fewer parts meant fewer steps, fewer robots, less maintenance, and lower risk of breakdowns. Every layer of complexity they could remove wasn't just a cost savings, it was an efficiency multiplier. This thinking, cutting problems at the root rather than treating symptoms, is what sets Tesla's manufacturing philosophy apart. It's not just about innovation in technology, it's about innovation in thinking. Giga casting doesn't just matter because it speeds up Tesla's production. It matters because it represents a paradigm shift for the entire automotive industry. If others want to keep pace, they will have to rethink their entire production philosophies. Traditional automakers, whose supply chains and factories are optimized for assembling complex multi-part underbodies, are now faced with a tough decision. Either invest billions of dollars into adopting new manufacturing methods or risk falling behind in cost, quality, and scalability. Some companies are making moves. Volkswagen, for example, has announced its interest in using large casting technologies for its next generation of electric vehicles, while others are cautiously exploring partnerships with specialized casting firms. However, Tesla's multi-year head start is already becoming evident. More than just a manufacturing trick, Giga casting may become the defining feature that separates winners and losers in the electric vehicle era. While the world marvels at Tesla's cars, the range, the acceleration, the self-driving features, few realize that one of the company's greatest advantages is invisible to the customer. It's happening deep inside the factories, where giants like the Giga Press hum day and night, reshaping molten metal into the building blocks of the future. In a world where manufacturing often feels incremental, Tesla has shown that radical leaps are still possible, if you're willing to rethink everything from the ground up. So now the big question is, what's actually inside the Giga Press? What makes this beast of a machine so different from anything that came before? At first, the term 50,000-ton Giga Press sounds almost mythical. It invites a series of questions. Is it the machine's weight, its size, or simply a marketing exaggeration? In fact, the 50,000 tons refer not to the mass of the Giga Press, but to the clamping force it can generate during the casting process. It is the sheer pressure the machine applies to seal the two halves of a mold while molten aluminum is injected into it. Rather than being about how heavy the machine is, the true magic lies in how hard it presses, and this distinction changes everything. To better understand the scale, it is worth noting that the first Giga Press units developed by Idra Group in Italy operated at clamping forces between 6,000 and 9,000 tons. Even at those levels, they represented a transformative leap in manufacturing capability. Therefore, when Tesla introduced the idea of scaling this up to 50,000 tons, it caused a ripple of disbelief across the industry. This amount of pressure is comparable to the weight of an entire aircraft carrier, focused onto a mold to shape metal with incredible precision and speed. The Giga Press operates using the principles of high-pressure die casting, but on an unprecedented scale. The process begins with melting specialized aluminum alloys at extremely high temperatures inside industrial furnaces. Once fully molten, the aluminum is rapidly injected into a precision-machined steel mold, crafted to replicate the exact form of the desired vehicle component, such as the underbody of the Model Y or the Cybertruck. As the liquid metal floods the mold, the two mold halves, enormous mechanical hands, are clamped together with overwhelming force. The goal is simple yet technically daunting: to ensure the molten aluminum fills every cavity, corner, and contour before solidifying. Any delay could cause cooling to occur too early, leaving air bubbles, gaps, or other casting defects. Precision in timing and temperature control is critical. If the metal cools too soon, it will not completely fill the mold. If the flow is too slow, structural weaknesses may form. To counter these challenges, Tesla has engineered a sophisticated cooling system that regulates temperature uniformly across the mold surface. This careful control allows the aluminum to harden evenly, producing parts with exceptional structural integrity and tight dimensional tolerances. Once solidified, a robotic system extracts the casting, removes any excess material, and passes it through rigorous quality inspection processes to verify it meets the company's strict standards. The implications of this process go far beyond speed. By creating large vehicle structures as single castings instead of assembling them from dozens of separate parts, Tesla achieves a remarkable trifecta: reduced vehicle weight, increased structural rigidity, and accelerated production timelines. Unified castings eliminate the need for hundreds of welds and fasteners, removing potential weak points and reducing the risk of assembly errors. Fewer parts mean not only lighter vehicles, but also fewer sources of mechanical failure over time. Moreover, the simplified manufacturing flow enables Tesla to build vehicles faster and more cost-effectively without sacrificing quality. This manufacturing innovation is not merely technical. It reflects a philosophical shift in Tesla's approach to engineering. Rather than seeking marginal gains within the traditional methods of car assembly, Tesla chose to rethink the entire process from first principles. The company asked fundamental questions. Why weld together so many parts when one could be cast? Why manage complexity when simplicity could lead to superior outcomes? This mindset, favoring radical reimagination over incremental improvement, underpins the success of the Giga Press. Tesla's boldness has not gone unnoticed. Today, other automakers are racing to adapt similar technologies. Companies like General Motors, Hyundai, Volvo, Zeekr, and XPeng have all announced investments in large-scale casting equipment. In particular, XPeng's investment in a 16,000-ton Giga Press signals the seriousness with which competitors view this next-generation manufacturing method. Nevertheless, Tesla maintains a crucial multi-year head start, having already integrated large, casting practices into their production lines and vehicle designs, while others are still in the adaptation phase. It is important to recognize that the Giga Press's true impact extends far beyond Tesla's factories. It's setting a new standard for how vehicles, especially electric vehicles, will be manufactured in the future. Simpler, stronger, lighter, and cheaper cars are no longer a distant dream, but an inevitable reality for the companies that can master this technology. Deep inside Tesla's gigafactories hidden from public view, the Giga Presses operate day and night with deafening efficiency. They are not merely tools of production. They are monuments to a new philosophy of industrial design. In a world that often changes incrementally, Tesla has demonstrated that profound leaps are still possible, but only if you are willing to question everything, rebuild from the ground up, and press harder not just with machines, but with ideas. In the end, the Giga Press symbolizes more than just mechanical force. It represents the triumph of first principles thinking in the age of electric vehicles. A silent giant fueling a very loud revolution. Under Elon Musk's leadership, Tesla isn't just building cars, it's redefining how cars are made. At the heart of this revolution lies the Giga Press, massive machines capable of casting an entire vehicle chassis in one single shot. Given the dramatic advantages of this technology, cutting costs, speeding up production, and reducing labor, one might wonder, why doesn't Tesla apply Giga Press to all of its models? Replacing hundreds of stamped, welded, and machined parts with a single-piece casting has allowed Tesla to slash 30 to 35% of the rear underbody production costs for the Model Y, saving roughly $8,000 per vehicle by 2025. For the upcoming affordable Model 2 with its entire body cast as one unit, the savings could reach 50 to 60%, or about $15,000 per car. Beyond cost, Giga Press revolutionizes production speed. While traditional body production takes 35 seconds per piece, Tesla's Giga Press process can produce 5 structures in 5 seconds, a staggering leap compared to conventional automotive manufacturing. Yet, applying Giga Press technology across all models is far from straightforward, as the process demands exceptionally strict operational conditions. First, casting tolerances are critical. When molten aluminum is injected into the mold, it must perfectly fill a highly complex cavity within milliseconds. For larger vehicles like the Model S, Model X, or Cybertruck, the extended metal flow paths increase the risk of air entrapment and casting defects. Second, thermal dynamics management poses another challenge. If the injection speed is too fast, it can create air bubbles that weaken the structural integrity. If it is too slow, the metal may cool prematurely, resulting in incomplete mold filling. Finally, material limitations must be considered. High-performance models often require a strategic mix of different materials, such as aluminum, steel, and carbon fiber, to achieve optimal strength and performance characteristics, a level of complexity that is difficult to accommodate with a single-piece casting approach. In short, Giga Press works best for simpler, smaller vehicles, designed for high volume and cost efficiency, not for complex, customizable premium models. Deploying a Giga Press is a massive investment, from the machine itself to the specialized molds and automated systems that support it. To justify the cost, Tesla must manufacture hundreds of thousands of units per year. This is why high-volume models like the Model Y, Model 2, and Cybercab are ideal candidates, with expected production numbers between 500,000 and 2 million vehicles annually. At this scale, fixed costs spread thinly over each unit, unlocking aggressive cost advantages. Meanwhile, vehicles like the Model S, Model X, and even the Cybertruck have far lower production volumes and higher degrees of customization. For these, Giga Press would not yield the same economic benefits, and might even increase per-unit costs due to machine underutilization. A Giga Press produces an exceptionally rigid chassis, but that rigidity comes at the cost of design flexibility, which is perfect for models like the Cybercab and Model 2, where simplicity, durability, and affordability are the primary goals. However, for premium models like the Model S and Model X, customers expect a smoother ride quality, which is achieved through flexible structural tuning. They also demand highly customizable design options and advanced safety systems that rely on modular construction techniques. The use of a one-piece casting would limit these critical features, potentially compromising the luxury experience that customers anticipate from higher-end vehicles. Most importantly, Tesla isn't just optimizing one vehicle, it's inventing an entirely new production paradigm. Instead of traditional linear assembly lines, AI-driven robots operate in a distributed network-like layout, and large single-piece castings snap together like Lego blocks. So if the Giga Press is truly Tesla's secret weapon, why are major automakers like Toyota and Volkswagen still hesitant or slow to adopt this technology? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
Shape the cars we currently make, and but the key is that they'll be affordable and you'll be able to buy one.
I think it'll be able to produce a car ultimately in less than 5 seconds. Can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
A Tesla Model 2 for just $10,050 in 2025. Would you dare to buy it? Elon Musk has just unveiled the tested version of Tesla Model 2 with specs bold enough to shake the entire auto industry. But what truly sent shockwaves around the world wasn't its performance, range, or tech. It was the price, $10,050. Sounds unbelievable? We thought so too. But make no mistake, Tesla definitely never takes a loss and sells at a loss because this isn't a clearance model or a used gas car collecting dust on a dealer lot. This is a brand new Tesla, engineered with the same premium DNA the brand is known for.
It doesn't make bad cars, and we always make, our intent is not to make a car that is any worse than any car we've ever produced in the past.
So, what secret tech has Tesla been hiding? And how is the Model 2 so insanely cheap? Can a $10,050 price tag really hold up in today's chaotic economic and political climate? Just wait until you see the exact numbers in today's explosive episode of Tesla Car World. So, what's the hidden secret behind the Tesla Model 2's $10,050 price tag? Never before has a Tesla come close to this price point. $10,050? Yes, but that number is real, and it's not a gimmick. What's hiding behind that shockingly low price is a brilliant 5-part strategy crafted by Elon Musk, specifically for the Tesla Model 2. And we've uncovered every piece. Let's start with what's arguably the boldest move in Tesla's playbook, an aggressive, almost reckless production plan for the Model 2.
Because then we can make, in a single casting machine, we could do like 5 at a time or something. I'm trying to think, how do you scale castings? Because you got liquid metal's got to cool, and then you've got to automate, getting all the bits and pieces off the casting so it's usable.
Elon Musk once claimed that the Model 2 would become the most mass-produced vehicle in Tesla's history, with a staggering 50 million units projected, more than all other Tesla models combined. At first, we thought it was just another one of Elon's bold exaggerations. But when Tesla revealed its 50,000-ton Giga Press manufacturing tech, one thing became crystal clear: that the era of mass-producing EVs, by the second, has officially begun.
Sure, why not? Let's 50,000 tons.
This is, quite literally, the first die-casting machine in the world capable of producing 5 vehicle bodies in a single cycle. and when paired with a compact, minimalist design, like the Tesla Model 2, that number could jump to 8 or even 10 frames at once. You're probably thinking, no way. How is that even possible? But right now, Tesla is already using a 9,000-ton version to build the Cybertruck. But that's just the appetizer. The 50,000-ton Giga Press, the largest casting machine ever built, is being installed as we speak. Custom engineered for Tesla's next-gen EVs like the Model 2 and the Cybercab, this beast is so fast and powerful. Elon Musk says it operates like a high-speed consumer electronics assembly line, moving so rapidly, no one can even get close.
It looks like a really high-speed consumer electronics line. In fact, the line will move so fast that actually people can't even get close to it.
Elon Musk has confirmed that the production line for this vehicle involves an entirely unprecedented manufacturing process, engineered specifically to meet Tesla's bold production targets. And now, with Musk unveiling the new Giga Press, it's crystal clear that this machine is the beating heart of Tesla's lightning-fast Model 2 rollout. Building an entire car in just 5 seconds would mark a breakthrough the auto industry has never witnessed before. For comparison, Tesla's Gigafactory in Shanghai currently produces a Model Y every 35 seconds, making it the most productive car plant in the world, as confirmed by Lars Moravy, Tesla's Vice President of Vehicle Engineering. That stat isn't hype. You can find it cited in multiple reputable news sources. Now consider this. The Model 2 is about 15% smaller than the Model Y and has been engineered with radical simplicity. That 5-second goal? It's not just ambitious, it's within reach. Thanks to its monolithic cast design, the Model 2 may become the first truly mass-market EV to hit that milestone. A Tesla engineer involved in the next-gen EV program shared that the Model 2's structural frame will be made up of only around 80 parts, compared to over 200 in the Model Y. That's a 60% reduction in structural components, dramatically simplifying both assembly and final production. With this ultra-minimalist design paired with the brute force of the 50,000-ton Giga Press, slashing production time from 35 seconds to just 5 isn't a fantasy. It's Tesla's next industrial leap. Alongside its upgraded production systems, Tesla is making a bold leap forward with its Gigafactory in Mexico, a massive 8 million square foot facility designed to support the company's long-term ambition of producing tens of millions of Model 2 vehicles. But this isn't a one-location effort. Tesla is rolling out parallel production across North America, Europe, and Asia, creating a global synchronized manufacturing network. What sets Tesla apart is its modular production line design, which allows a fully operational factory to come online in just 6 months, a timeline that leaves traditional automakers who often take years in the dust. To insulate itself from raw material price volatility, Tesla has secured strategic long-term agreements to lock in battery material costs at 40% below market rates for the next 8 years. At the same time, with 92% vertical integration, compared to the industry average of just 40%, Tesla controls nearly every part of its supply chain, giving it unmatched command over quality, cost, and innovation. Tesla's supply chain is also powered by AI-driven logistics, which have cut inventory by 65% while improving part availability, thanks to real-time predictive analytics and just-in-time delivery systems. All of this forms the foundation for Tesla's ultra-efficient manufacturing strategy. Through 17.5 million AI simulations, Tesla has optimized every inch of the vehicle's design. The Model 2 features a biologically inspired honeycomb chassis that absorbs crash energy more efficiently using less material, combined with gigacast aluminum frames and SpaceX-grade ultra-durable glass. Together, these innovations have driven down production costs by up to 78%, enabling Tesla to price the Model 2 aggressively while still remaining profitable. With this strategy in motion, Tesla is well on track to meet its production goals: 250,000 units by 2026, 1.5 million by the end of 2027, and ultimately, the staggering target of 50 million Model 2s. And with cars soon being manufactured in mere seconds, this isn't just the future of automotive production, it's happening right now. Next comes the part that really matters to most buyers, the actual price you'll pay. Let's set the record straight. The $10,050 price tag on the Tesla. Model 2 isn't marketing fluff or a starting from number with fine print. It's the real all-in cost, with zero hidden fees. If you've ever bought a car the traditional way, you probably remember thinking the sticker price was the final deal, until the dealership hit you with up to $3,000 in extra charges. We're talking about shady prep fees, forced accessories you didn't ask for, and paperwork costs that seem to come out of nowhere. It's frustrating, and worse, it's common. But Tesla plays a different game. The Model 2 is sold directly to you, no dealerships, no middlemen. And what you see is truly what you pay. Tesla's transparent pricing model doesn't just simplify the buying experience, it can save you thousands of dollars compared to going through a traditional dealership. And here's where things get even more impressive. The $10,050 price tag for the Tesla Model 2 is calculated after factoring in all applicable incentives and discounts. This includes a wide range of support from both federal and state programs that significantly lower the out-of-pocket cost for buyers. For starters, there's the $7,500 federal tax credit, which applies to qualifying electric vehicles. On top of that, depending on where you live, you could receive up to $4,500 in state-level incentives. Many utility companies also offer rebates ranging from $500 to $1,200 just for switching to an EV. And for senior citizens in 14 states, there are additional incentives between $200 and $750 specifically designed to make electric vehicles more accessible. In markets like New York City and Los Angeles, where all of these benefits can stack, the final cost of a Tesla Model 2 could fall to under $7,000, making it cheaper than many used gas cars on the market today. But the real savings begin the moment you drive off the lot. Let's break it down. The total cost of ownership for a Tesla Model 2, including the purchase price, electricity, insurance, and maintenance, comes to just $17,245 over 5 years. Compare that to a Toyota Corolla at $28,800 or a Honda Civic at $30,400, and you're looking at a minimum savings of $11,500. So where does all that money go? It comes down to the Model 2's fixed, low-cost ownership structure, which eliminates many of the recurring expenses that gas-powered cars require: no oil changes, no spark plugs, no transmission flushes, and also no radiator repairs. In fact, Tesla estimates that maintenance costs alone are $4,700 lower over 5 years compared to a gasoline car. Add that up, and the 5-year savings hit $11,500. Stretch that out to 15 years, and you're looking at a potential lifetime savings of $37,500, enough to buy a second Model 2 outright. On top of all that, the Tesla Model 2 offers flexible financing options that make it even more affordable, often cheaper than buying a used car. With a 60-month loan at 5.9% interest, monthly payments come out to just $223. Prefer a shorter term? A 36-month plan at 4.5% interest brings the payment to $343 per month. And for customers paying in full, there's even more good news: a $500 discount for cash buyers over a certain age, bringing the total price down to just $11,079. In a world where affordable financing is rare, Tesla is offering not just a low-cost car, but a realistic path to ownership. So, how exactly does Tesla plan to produce 5 million Model 2? It's an ambitious target, but given Tesla's current capabilities, it's not just possible, it's entirely within reach. The company is executing a bold global strategy built on simultaneous high-efficiency production across 4 continents. Tesla's key production hubs, Texas, Mexico, Berlin, and Shanghai, are all being scaled up to manufacture the Model 2 in massive volumes. What makes this plan so effective is Tesla's use of standardized modular production units that can be quickly replicated and deployed worldwide. These modular lines are engineered for speed, flexibility, and scalability, cutting down setup time from years to just months. The result? Delivery timelines that once stretched from 8 to 12 months for high demand models will be slashed to just 4 to 6 weeks. That's faster than ordering a custom-built laptop, except in this case it's a fully electric smart vehicle built for the masses. For example, by the first quarter of 2027, Giga Texas is expected to deliver 1.2 to 1.3 million vehicles. In the second quarter, Giga Shanghai will ramp up to around 1.4 million units, followed by Giga Berlin with 1.1 million units in the third quarter, and finally Giga Mexico, projected to hit 1.7 million units by the fourth quarter. What makes this plan unique isn't just the scale, it's the strategy behind it. Tesla is achieving what many in the industry call the impossible triangle, combining affordability, long range, and high performance into a single vehicle without compromise. No other automaker has successfully hit all three points at once. Tesla is also shifting its marketing focus like never before, targeting first-time car buyers and aiming to become their first and possibly only car brand. And thanks to its global manufacturing standardization, a Model 2 made in Mexico will be identical in quality to one built in Berlin, Texas, or Shanghai. In other words, no more factory lottery, just consistent excellence no matter where your Tesla comes from. What is the new battery of the Tesla Model 2 2025? Tesla has made remarkable progress in battery technology in recent years, especially with the development and in-house production of their advanced 4680 cells. However, those high-performance batteries are currently reserved for premium models like the Cybertruck and Semi. When it comes to the Model 2, a more cost-effective solution is on the table. Lithium iron phosphate batteries supplied by China's CATL. Now you might assume that a cheaper battery means underwhelming performance, and you'd be partially right. For drivers who expect over 300 miles of range and sports car-like acceleration, the Model 2 may not be thrilling. But for anyone looking for affordability and practicality, this could be the best performing EV in its price range, by far. In Tesla's Master Plan Part 3 released before, the company confirmed that the Model 2 would come with a 53 kilowatt-hour LFP battery pack. While it's not designed for ultra-long range, one variant will offer at least 250 miles on a full charge, which is a standout achievement for a vehicle priced under $30,000. Expect multiple configurations, including both single-motor and dual-motor versions. Thanks to a weight reduction of roughly 30% compared to the Model Y, this compact EV will go farther on less energy. A long-range version could realistically reach up to 280 miles. The Model 2 will feature CATL latest generation LFP cells, which offer greater energy density than those used in Tesla's current Model 3 and Model Y LFP-equipped versions. Higher density means more energy stored in the same space, which leads to a lighter and more efficient battery pack. Another key advantage? Fast charging. CATL claims that its updated LFP batteries can charge from 0 to 80% in just 10 minutes. Realistically, though, due to thermal and system-level variables, a 20-minute charging time feels more believable. Even so, that's incredibly fast for a vehicle in the $25,000 range, well beyond current market expectations. Since batteries account for nearly 50% of an EV's total manufacturing cost, choosing a compact and cost-efficient LFP pack is crucial. While these batteries may not compete with high-end cells on raw performance, they win with their safety, longevity, charging speed, and affordability. Today, roughly 70% of all Teslas already run on LFP batteries. The more expensive 4,680 models are reserved for high-performance models. This proves that for Tesla, LFP is the perfect match for the mass-market Model 2. Tesla is planning to produce LFP batteries domestically at its Giga, Nevada factory, with equipment and technical support from CATL. By localizing production, Tesla could make the Model 2 eligible for the full $7,500 U.S. federal tax credit. How can Tesla maintain a $10,050 price tag while claiming it never sells at a loss, especially amid global fluctuations in battery, material, and manufacturing costs? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.